Hello students, I am sure the title and length of this video is very encouraging to you. Maybe you have a test tomorrow morning, maybe you have a test this morning, maybe you have a test in 10 minutes and you're now looking at this video for the first time. Whatever the scenario, I will gladly take you along for the ride to a safe destination. Alright, so the definition is of dy dx is simple. It's just dy dt divided by dx dt. So you know this very well. To differentiate y with respect to t is 1 plus t squared. At the top you have the 1 plus t multiplied by the differential of 3 plus 2t, which is just 2, minus, you put the 3 plus 2t, and then you differentiate 1 plus t, which just gives you 1. Expanding this bracket will give you 2 plus 2t minus 3 minus 2t. So that will just give you negative 1 over 1 plus t all squared. X dx dt is found the same way. We had 2 minus 3t over 1 plus t. So 1 plus t is squared. Right? Then we put a 1 plus t, we differentiate 2 minus 3t, we get negative 3, minus, we put a 2 minus 3t, we differentiate 1 plus t, once again, we get 1. Then we do some neatening up, negative 3, negative 3t, minus 2, plus 3t, that and that goes out. That is just left with negative 5, and we have that there. Dy dx then is simply, as we said, dy dt divided by dx dt. So dy dt, which is this, divided by dx dt, or multiplied by dt dx. Remember, if you divide by a fraction, simply upturn and multiply. That goes out with that, and we just have 1/5. And that is parametric equations. Example 2. Alright. Let's say we have y is equal to that, x equal to that. Here we're going to go to the second derivative. Find dy dx and the square y dx squared. Now we know once again that dy dx is simply dy dt divided by dx dt. Now what is dy dt? You just differentiate this and you get 4t cubed minus 16t. What is dx dt? Differentiate this and you get 30 squared plus 60. There's a note here that says this will be used twice. This dx dt will always be used twice when you have to find the second differential of a function. Alright, next. So dy dx is simply dy dt divided by dx dt. I didn't have to upturn anything here since none were fractions, right? So just that divided by that is that. And the other part I have in brackets here, this is the first use of dx dt. Dy dt divided by dx dt. I have t in every term. And I see each term has a common factor, so I just put out the highest common factor from the numerator and the denominator. So that's why I factorize and I got this. Now, you could leave your answer as this and move on, or you can realize that this is the difference of two squares. Now, the difference of two squares just pops up without warning and makes the question simpler. Now, how do you know when to look for a difference of two squares? If you see something with, well, remember limits, the last time we used one in a test, it was because we had 1 minus e to the x squared. We had 1 minus e to the x squared divided by 1 minus e to the x. Right? Of course, it was written as e to the 2x, which is the same as e to the x squared. And this was rewritten as 1 minus e to the x multiplied by 1 plus, well, I think this was a plus, 1 plus e to the x all over 1 minus e to the x. Alright, this was indeed a minus. Anyways, it wouldn't matter. for this explanation. So this will go to that, so it's just 1 minus e to the x remains. Now, what you always look for when you would want to check to see in you mentally if there is a difference of two squares, if you see something with a number and a letter in the denominator and a number and a letter in the numerator, and it has different signs, just check to see if any difference of two squares thing is happening there, where you could simply expand the difference of two squares and do a factorization. Now, it could be a letter. Well, this is practically just a number. It could be a variable, I should say, like x, 1 minus x squared. Like, for instance, if I have 1 minus x squared over 1 plus x. This is an example. We have a number and a letter at the top, and a number and a letter at the bottom, but the signs are different. This is a very suspicious candidate. So what would I do? I look to see if there's a difference of two squares. Yes, there is a difference of two squares. This is a number squared minus the next number squared. Right, where x represents a number. So I do 1 minus x times 1 plus x all over 1 plus x. And that's why I can factorize those or cancel that and just be left with 1 minus x. And so that's how you know when to look for the difference of two. I know those who are versed in maths don't need these simple explanations, but these videos are made considering every single person, right? So I see a number and a letter and a number, and I see signs change. Let me look for a difference of two squares. Yes, I do see a difference of two squares because I see something squared here minus something squared here. What is 4? It is just 2 squared. So this is then t minus 2 multiplied by t plus 2 all over the same t plus 2, and this is cancelled out, and you just left with this. I want a part 2 to find the second derivative. Now, if you don't find a difference of two squares, I wouldn't mark it incorrect, but it would make the second step longer because this would be an answer, and the second step you'd have to do something with a quotient rule. And well, if you get a question right in the end, it is still acceptable, but in an exam, the time allotted won't cater for you taking a long way around for every question. So just keep your eye out for when you can make something shorter. Alright, so that's the dy dx. Now on to part 2. Find the second derivative. Now the second derivative, by definition, means we differentiate our first derivative with respect to x. But our first derivative was 4/3 of t minus 2. So we have d dx of 4/3 t minus 2, which is t is the variable, and t is not a function of x, right? So we can't differentiate this with respect to x. But this is the same as d dt of that multiplied by dt dx. Right? Don't look at the side note. This is the same as that. And in general, what you could do, if you have d dx of something, you write the d here, and then write a d back here, and then write a dx way over there. And whatever is a variable, you put that dt there, and you put it there. If it's t, it is a variable, you put dt there and dt there. Right? That's a shortcut. But this and this would go out, and this is still equivalent to d dx. This t will cancel, so it's still d dx, which is here. So you didn't change anything. This is the same as this. Now the side note just says this is our second use of dt dx. Remember I said that this dx dt would have been used twice. Right? So this is our second use because dt dx is just a reciprocal of dx dt. Right? Now dx dt, we had found this to be 3. To be that now, which means dx dt is this and dt dx is just a reciprocal of it, just that. So let's go. We have dt of this. I just multiplied out this bracket 4/3 of t multiplied by minus 8 over 3 times dt dx. Now, this written here, please don't ever think this is a product rule, even though if you look at it in a way, you might think it's a product rule. And even I would sometimes, if you look at it long enough, you might think, oh, let's use product rule because I have ddt of something, of a function of t multiplied by the next function of t, and it is very easy to just negligibly or neglectfully, just say something like that. But I don't know if that was a word. Anyways, finding ddt of this, we just have, well, 4/3, differentiate 4/3 t with respect to t, just 4/3. This would go to 0, and this just comes down there. We don't touch this. This is ddt of this, so when you finish work, not multiply by that. So that is that there, and that's our answer. Example 3. I don't want this video to pass 12 minutes because of this. It's the day before the exam, so we'll just work with example 2, 1 and 2 for the test tomorrow. Alright, all the best. Goodbye.